So this worksheet, energy flow diagrams. Basically what I want you to do is I want you to look at the scenario that's provided and then tell me what happens as far as how much energy it starts with which type of energy, as well as the final. So the transition in between is not really that important. I just want to know how much of each type of energy it starts with and how much of each type of energy it ends with. Okay, so a couple things to kind of keep in mind. We're going to go through this first one together. First off, if I have little squiggly lines behind it, then that means that that object is still moving. So if it's moving, then that means it's going to have kinetic energy. Okay, so let's look at the beginning. Let's look at the initial first. It says that the initially we're not moving. Okay, so we have zero kinetic energy. Initially, we don't have any height. If you remember, gravitational potential energy deals with height, and when we're at the lowest point, then that means we have no gravitational potential energy. All right. So as far as springs are concerned, we have this, initially we got this little thing right here, and it looks like kind of springs that are about to push the cart. So we have some spring potential energy. Now at the beginning, dissipated energy simply refers to friction. Now you'll notice in this problem it says no friction. So we're not going to have any dissipated energy at the beginning, nor are we going to have any at the end. All right. So if we do have friction, for example, number 2 says with friction, then the amount of dissipated energy is going to start at 0 and it's going to increase from there. Okay, so let's get back to number 1. We have the kinetic energy that starts with 0 kinetic energy, but then it's moving a little bit here. So I'm going to give it one little box upward. All right. Also, when it gets to this top part, it's going to have some height. So if I look at gravitational potential energy, I have some height, which means I do have some gravitational potential energy. We have no spring at the end. All right. The spring is already released. It's given all its energy. So now we have no spring that's here. So it's going to be 0 there. All right, so this is a completed scenario, and basically there are several things I want you to keep in mind. All right, when you do this scenario from beginning to end, these are the 3 things I want you to show in your scenario, okay? The amount of energy that you start with is going to be the same as the amount of energy you end with. So what you start with and what you end with need to be the same. So start energy needs to equal the end energy. So you'll see here in this example, I start with the first one. Spring has 3 levels high, and each one of these is an equal amount. Now, do you have to have 3 levels? No, you can have 2 if you'd like, just as long as when you come over here to the end, you have 2 as well. So mine is 3 high. So when I add these 2 together, the kinetic energy added to the gravitational potential will give me 3 high as well. That tells me that there's conservation of energy. Okay, the next thing I want you to know is knowing which types of energies are present. Okay, so with no friction, we don't have any dissipated energy. With a spring, we are going to have spring energy, but the spring energy is at the beginning, but not at the end. And then when we have height, we have gravitational potential, but with no height, like at the beginning, we have no gravitational potential. And then kinetic energy is obviously seen in the motion. So each one of these energies are indicated in the problem. Spring by a compressed spring, the gravitational potential by how high it is, the kinetic energy by whether or not it's moving, and then dissipated energy of how much friction it has, if it has any at all. The third thing I want you to show is how the appropriate energies are present and how they increase or decrease. So I want you to indicate whether they're increasing or decreasing. And you can see that by the graph. So kinetic energy increases because we start with 0 energy, 0 kinetic energy, 0 motion, and then now we have motion at the end. For the gravitational potential, it starts with 0 and it increases as well. The spring energy starts with all the energy there and then it decreases. So in order for energy to conserve, you have to have energy transfer from one type to another. So some energies have to decrease, some energies have to increase, but the total amount you start with is equal to the total amount that you end with. That's what I want this worksheet to be able to show. Okay, so a couple things to keep in mind. We've already talked about how lines behind it means it's moving. A compressed spring means you have spring potential. If you have friction, then that means you start with zero dissipated energy and it increases from there. Again, I don't care how high you go on each one of these, just as long as the total amount you start with is equal to the total amount that you end with. All right, so this third scenario, you see that it starts with an initial velocity that's greater than zero. So there is motion. I should have squiggly lines behind it, but I don't. So it is moving, but it has zero height. So that should indicate something about gravitational potential. Then as it goes up this incline, it has zero velocity, but it does have some height, and it says no friction. So that should indicate what energy you start with and what energies you end with. This one right here deals with a person that's pushing it. Now, we don't have really a name for that. So I left a little question mark with a blank. And basically what I want you to do is I want you to get creative. Just tell me in one word what energy this person is supplying. And you can call it whatever you want, just as long as it's school appropriate. All right, we start with initial velocity of zero, initial height of zero. At the end, we have a final velocity that's zero as well, and the guy is laid over. He has no more energy left, but we do have a height. Now, the reason we have no final velocity is because it says the parking brake is engaged. So hopefully that indicates to you that when the parking brake is engaged, there's friction involved. All right, this one right here, we start at the bottom where the spring is compressed. Here, the spring is uncompressed, so there's no spring energy at the end. Start with zero velocity, zero height at the beginning, and at the end, we have height, but it says we also have velocity, so keep that in mind. Same thing here, we start with a compressed spring, but then that block is then released and goes up here. Now, keep in mind that even though it's on a level surface up here, it's still at a higher height than what it started at. Even though it's on a level surface, it still ended at a higher height than what it started at. All right, so that should indicate what happens to each one of your energies as you go through this. So go ahead and complete that and be ready to answer the questions in class.